A consumer protection group claims that the average amount of time Facebook users spend on the site each day is more than 50 minutes. If a random sample of 120 Facebook users is monitored and their average time spent on the site each day is 52.2 minutes, what is the critical value and rejection region for a test of the group's claim at the 1% significance level? Okay, so the very first thing you need to do if you're trying to find the critical value and the rejection region is to determine what the claim is in the problem. So let's look at that. So this consumer protection group claims that the average amount of time spent on the site is more than 50 minutes, right? So greater than. So the mean is greater than 50 minutes. Okay, and if that's your claim, then your corresponding null hypothesis and alternative hypothesis. All right, so with this symbol that we see in the claim, we know that's a symbol that belongs to HA. So we're going to say the mean is greater than 50 here. That's your alternative hypothesis. And that means that the null hypothesis would have to represent the opposite argument or the complementary argument. So if you want to say that a number is not greater than 50, it must be that it's what? Less than or equal to 50, right? Okay, so there's your null hypothesis and your alternative hypothesis and your claim. Now from here, what we want to do is to go ahead and determine what alpha is in the problem. And it says that alpha here is 1% or 0.01. And then we also want to pay attention to the symbol that HA is using, right? And we're going to say, hey, look, HA is using a greater than symbol. This kind of looks like an arrow, right? It almost looks like an arrow pointing to the right. And that means it's a right-tailed test. So we can remember that simple rule that the test is right-tailed when you use a greater than symbol. If they use a less than symbol, it's a left-tailed test. And then for a not equal to symbol, it's two tails, right? So this would be left-tailed, and not equal to, of course, is two-tailed. And those are the only three cases that you can have. So that basically covers it. So in our case, we know it's a right-tailed test. And what this means is that all of that alpha will be put into one tail in our drawing, right? Again, we're just using this drawing as a visual aid, right? So we draw a bell curve. We know that we should be using a z distribution here because the sample size is quite large, 120 Facebook users, and that's big enough to assume that the sample mean has an approximately normal distribution. So we can say that alpha here, this alpha here, is all in one tail, right? Because we only have a one tail test, so the full significance level, the full alpha is put into one tail. So all we have to do now is go to the chart and look up 1% in one tail. So we'll go to our t-chart to see if we can find this value. So here we are on our chart, an area in one tail. We do indeed have 1%, so we can get it from the t-chart. Now again, because the sample size is large, we'll actually be using a z critical value. So we'll go all the way to the bottom where we can find that quantity. And at the bottom of that column, we have 2.326. So that means this number down here is 2.326. Now we do have to pay special attention to whether or not this number should be positive or not. Remember, the table will always give you positive values, and it is appropriate that this is positive because it's to the right of 0. Now, that's your critical value, so that's nice. We have the critical value. It's equal to 2.326. But what is the rejection region? Well, remember, over here, we'd say do not reject, right? So if you're on the number line in this area, you say do not reject the null. But over here, once you cross this little line, you're going to say that this is where you would start to reject the null hypothesis, right? So our rejection region is essentially as follows, right? Reject if your test stat z is greater than positive 2.326. And so that's your rejection region.